This is one of the laws that can be found on the basic set theory concepts. It's called the De Morgan's Law. Actually, there are two statements for De Morgan's Law. We are going to talk about the second on a separate video. The following laws will talk about equality of operations under specific sets. In this case, for the first statement for De Morgan's laws is that the complement of the union of set S and T is just equal to the intersection of the complement of S and complement of T. Now, we can assign values for set S and set T, but since set S and set T could be any type of set, it could be a finite set, an infinite set, or even an empty set itself, let us try to avoid using sample elements. But we can use a certain representation that can be true for this proof. So please bear with me. Let us try to assume that a certain x is an element of the left-hand side. And we are going to show that it's also an element of the right-hand side. If we cannot show that, that would mean this statement is not true. So let us try to assume that x is an element of the complement of the union of set S and set T. With this, since x is an element of the complement, then x then is not an element of the union. Because if we talk about complement, it's the other way around. So if x is an element of the complement, then it should not be an element of the union itself. Okay? Because if x is an element of the union, then it should not also be an element of the complement. Because once an element is on a complement of a set, it is not part of the set itself. With this, we can further say that since x is not an element of the union, x cannot be an element of S, or let's just try to use that what do you call this one, conjunction first, and it should not also an element of T. Because if we talk about union, when we try to combine two sets, the elements of that union could either be an element of an S, an element of T, or an element of both. Okay, so that would mean that if it's not an element of the union, then it's not an element of S, or that should be N. Sorry. Let me see. Let me just because N, yeah, it should not be element of both. Okay, it should not be an element of both. That's correct. Because if you're going to use or, so we can just simply pick one, and then the other one could be could allow it. But in this case, if it's not an element of the union, then it's not an element of S and not an element of T. Because even if it's not an element of S, if it's an element of T, it will be an element of the union. And since we have this negation, so we have that. What do we mean by this? If x is not an element of S, definitely we can say that x is an element of the complement of S. Okay? Because if one element or one object is not an element of a set, then it's an element of its complement. This is also true that if x is not an element of T, this would imply that x is an element of the complement. Since x is an element of complement of S and the complement of T, and x is found in both, and we have the conjunction here and, this would only mean that x is an element of the intersection is an element, yes, of an intersection of the complement of S and T. Because if it's found in both complements, it should also be found on the intersection. Because the intersection of any sets talks about the common element of those sets, whether they are complement or not. This provides us the idea that if we have here x is an element of the complement of the union of S and T, then x is also an element of the intersection of our complements of S and T. This shows the first De Morgan's law to be correct. So this is about properties, laws, and theorems. Please subscribe now.